All right, welcome to Chapter 4, Section 1, Representing Relationships. This is for Math 8. All right, so just a couple things like I always do, going over this front screen. So the first thing you should see on your student screen is a due date. I don't see it on the teacher preview, but you will see it on your screen. So it'll just tell you when it was or is due. Attempts, so this is the second thing we should see. I'm on attempt number 1 of unlimited attempts. And this means that I can submit this assignment as many times as I would like. I can just keep on coming back in and trying again and again and again until I get, the grade that I'm happy with. Number of questions, this just tells you how many questions are on this particular assignment. So this guy has 7 questions. Depends on the section there. We have anywhere from 1 to 10 questions per section. Just depends on what was available. So grading policy is always the best score. Whichever attempt is the best one is the one you get to keep. And partial credit is always enabled, meaning if I answer 1 of 7 questions, I get credit for 1 question. Please remember that once you start your homework, you always need to finish it before you can do anything else. What this means, this little warning, if I click, why didn't it click? Start. Then on the bottom right corner here for students, you won't see it on my screen here because again, teacher preview, but on the student screen, you will see a submit assignment button down here. When we're ready to leave this screen, we need to make sure that we click that button. There's a couple of reasons that we want to do this. The big one is that your teacher can't see anything that you're working on if you don't click submit assignment. It doesn't go in the grade book and we can't see it. So that's a big one. It doesn't affect the grade book. The second one is that if you don't click this button and you just leave the screen, like say you close the window, it's going to lock you out of every other assignment. It won't let you work on anything else until you come back in and click submit assignment. Remember, we have unlimited attempts. That means you can come back in here and try again. It's not going to take away any progress. So whichever number you stopped at, as long as you had them correct, it's going to give you them back. It's not going to, I said that funny, it's not going to give you them back as in like you have to do them again. It's going to check them off that you've already done them. So it's going to start you right where you left off, okay? So you don't start over again or anything like that. On the right side here, we have explanation, example, and message center. So explanation literally tells you you're going to lose your question attempt because it is going to give you the answer to this question. It's going to show you the solution. So it's not going to show you the answer and then say, okay, go type in the answer. You're going to have to come back in on another attempt and try that. The example just gives you a general example of what to do so we can see we're starting off with kind of a basic idea here. A boat is carrying containers that weigh 5,000 pounds. Here's a table that shows me I have a number of containers. If each container weighs 5,000 pounds, each is a multiplication word. So that probably means we're going to be doing some multiplication here. So 3 containers at 5,000 each weigh 15,000 pounds. 5 containers at 5,000 each weigh 25,000 pounds. 6 at 5,000 each weigh 30,000 pounds. So we type these in, that's what they're asking us to fill in, and then we're going to plot these on the coordinate plane here so that we can actually see the relationship between these two numbers, between the number of containers and the weight. So if we scroll down, we can kind of see this is a very linear relationship, meaning it's in a line. As the number of containers goes up, so does the weight, and it goes up by a certain amount each time. It's going to go up by 5,000 every time I add a container. That's the relationship here. So once I understand this and I know, okay, this is what they want me to do, this is how I work this out, then I can close that and I can click on example again if I want another one. I can also message my teacher straight from here, which will attach the question so that your teacher can see what's going on or where to come help you. All right, let's go ahead and take a look at this one. So instead of containers that weigh a certain amount, we have a store selling laptops for $900 each. I still have that word each, so I know I'm going to be multiplying. Use the information to fill in the table and plot the ordered pairs in the given by the table. So I have 2 laptops. If each one cost $900, here's my each, 2 at $900 each. Well, that's going to be $1,800, right? 900 times 2 is 1,800. So there's my first one. My second one, now I have 5 laptops and they're still $900 each. So I'm going to multiply and let's see, we get 4,500 this time. And I'm going to go ahead and do the last one before I jump back over here and type it in. So I have 8. And again, they're 900 each. So this is going to be 7,200. So one thing you can do too is I can just focus on this 9 when I'm multiplying. 9 times 2 is 18. 9 times 5 is 45. 9 times 8 is 72. And then I can add those zeros back on. So it's just a very quick way to do some mental math there so that you don't have to necessarily grab that calculator every time. If you're having trouble with the basic multiplication, like 9 times 2 and 9 times 5, 9 times 8, we should definitely know that at this point in math because we're in 8th grade. So there is a thing on this program called Quick Tables. If you go to the 3 lines up on the top left corner when you're in the home screen, you can scroll down to Quick Tables. And that's just, you know, back in elementary school when we did those timed math tests to kind of help build these math facts. That's exactly what Quick Tables is. It's just a very quick way to build those skills. I definitely suggest if you're having trouble with this basic multiplication that you go in and play with Quick Tables. All right, let's go ahead and graph these points. So I have 2 laptops, and that was $900. I have 5 laptops, and that was $4,500. And then I have 8 laptops, and that was $7,200. So we can hopefully see this is pretty linear. I can't really connect it perfectly in a line, but I can kind of see, I can follow that pattern with my eyes, it's a pretty linear pattern there, meaning it's in a line. Uh-oh, did I graph in the wrong spot? 72, what did I do? Oh, darn it. That's what I did. So the line is a little off. I was not looking at 2 was 1,800, not 900. Silly me. Now they're in a nice straight line. Okay. So let's go ahead and I'm going to erase. Whoops. Dang it. I'm just clicking all over the place here. All right. A gym has yoga class. Each class has 11 students. Each, I hear that word each. I'm going to be multiplying, right? So each class has 11 students. If there are C classes, so remember this is classes, this is the number of classes, right? So I can write number of classes. Write an equation to represent the total number of students, S, taking yoga. So we have students, and that's going to be S. Well, each class has 11 students. So if there's 11 for each class, every single class, then I would go 11 times the number of classes I had. 1 class would be 11. 2 classes would be 22 people. 3 classes would be 33 because I would multiply every time by the number of classes. And that's going to tell me how many students there are, right? If there's 1 class, there's 11 students. If there's 2 classes, there's 22 students. So this multiplication, this each, tells me the total number of students. So we're just kind of breaking that down and thinking it through a little bit there. 11C, and this does require us to remember what, we have to remember those kind of trigger words, the each. If I didn't know that that meant multiplication, I might struggle with how to write this. All right, an amusement park charges an admission fee of $25 per person. Per, that's the same thing as each. It means that we're going to be multiplying. So $25 for every single person that walks in that gate. The cost, which they're showing is a capital C in dollars, of admission for a group of P people, so however many people are going in, is given by the following. So I have the total cost is going to be equal to the ticket price, which is $25 per person. So every person that walks in the door is $25. If it's 1 person, it's going to be $25. If it's 2 people, 25 and 25, or 25 times 2 is 50. So this is just kind of the basic equation here. So now it says, what is the cost of admission for a group of 4 people? So I want to know what's the cost if it's $25 per person and I have 4 people coming with me. 25 times 4 gives me 100, and I think of quarters there. By 4 quarters, I have 100 pennies, right? 25 times 4. So that gives me $1 or 100 pennies. In this case, it's $100 because we're talking about $25, not 25 cents. But you can kind of relate that back to something that's a little easier to multiply out. And for whatever reason, you know, I like going back to kind of coins with money. Because 25 cents, I know if I have 4 of them, I have a whole dollar. So it's just kind of a simple way for you to relate those two things. Okay, now we're getting a little bit more complicated with this one. So let's see, we have Eliza, I think that's how you say that, Eliza purchased a prepaid phone card for $35.75. Calls cost 6 cents a minute using this card. The credit, C in dollars, credit means what's left over, left on the card after it is used for X minutes of calls is given by the following. So first, let's kind of think about this. And we might not know what a phone card is because that's really not a big thing anymore. Most people at this point have unlimited minutes, so we don't have to deal with this buying minutes idea. But not too long ago, this is how we had to do the minutes on our phone. We had to go to the store and buy a phone card that had so many minutes on it or so much money, and it cost a certain amount per minute to use it. So this is just kind of taking a step back before we had unlimited minutes here. So we have the phone card, and it had $35.75 on it total. This is what we started with. So this is our starting value, and we're subtracting how many minutes we're using. So we know it's 6 cents per minute. Remember, 6 cents a minute or every minute per minute. I can kind of replace these with those same words. So we need to kind of understand that that still means multiplication. Even though I didn't hear each or per, it's 6 cents a minute, every minute. So that's why we're subtracting 6 cents X. They told us X was the number of minutes. So now how much is left on the card if she calls for 30 minutes? So I have C equals, here's my original, my $35.75, minus 6 cents per minute. But now we know she's already used 30 minutes here. So we're going to need to multiply this together. So we're going to have 6 times 30. Let's see, we have 35.75. So when I'm doing this, I can actually ignore the decimal here for just a minute and go 6 times 30, and I get 0, 18, right? But now I need to put the decimal back. This was 1, 2, so I need to do the same thing and go 1, 2. So it's not going to be 180, it's going to be 180. So I can kind of do that. I could also write it out like this. 0.06, and I could actually multiply it, and I would get the same thing. You do not bring the decimal straight down, though. That is not what you do in multiplication. Once you get to the end here, so I'd have 0, I'd have 18, and I'd have 0, 0, and I'd have 0, 0, like this. So I'd have my 3 rows from my 6, 0, 0, because that's how many rows I should have. And now I add these together, so I get the same number that I got before, and I have to use this decimal to move this over. So it's 2 times here, I have to move it 2 times here. So same idea there. So we've used $1.80 of the $35.75. So now when I am doing this with subtraction, I'm going to just write it right under here so we can see it because it's a little easier to see. I do line up the decimals, and the decimal does come straight down if we're doing addition or subtraction. So now I'm going to subtract. 5 minus 0 is 0 or 5. I can't do 7 minus 8, so I'm going to need to borrow here. This becomes 17. So 17 minus 8 is 9. 4 minus 1 is 3. And then I have 3. So for 30 minutes, she spent $1.80, and she still has $33.95 left on that card. So $33.95. Alright, so we're going to do another one here. Working with our word problems. An amusement park charges an admission fee of $50 for each person. Ooh, I heard that trigger word, each. So I know I'm going to be multiplying $50 per person for each person. Let C be the total cost. So this is going to be my total cost. And remember, if I have so many people, I need to multiply every person by $50. It's going to be 50 times P, since they're telling me to use P for people, and it should be a capital P too. Be careful about that, because you want to make sure you're using the exact variables they're asking you to use. I don't think they'll mark you wrong yet about capital to lowercase, but they will in fact give you grief about it, because they told you to use capital C and capital P. So be careful when you're using your equations here. So we have C equals 50P, like that. So there's my equation. Now I can calculate the second part, which says cost for 17 people. So I know there's 17 people here, and each person costs $17, right? Or $50. So with this one, might just be easier to write this off to the side. We have 0 and 35. We have 0 and we have 5. Plus I have 0, 5, and 8. So I have the cost is going to be $850. And you know, there's other mental math ways to do that too if you didn't want to have to do the multiplication, but multiplication, just doing this off to the side, works just as well. All right, let's go ahead and check that, and a couple more here. Oh, I forgot I have to do that. Okay, so construction crew is lengthening a road. The road started with a length of 58 miles. So it started, whoa, why did it go to marker? Started with 58 miles. So started, that's very important. That's telling us where we're starting, quite literally. The crew is adding 3 miles of road each day. So it's plus 3 miles per day that they work. So we're starting to write a little equation here already, just by thinking about these two pieces. We're starting at 58 miles. After day 1, they'd have 3 more miles than that. After day 2, they'd have 6 total miles more. So it's not 6 miles total, it's 6 miles more than the 58. They already have 58 miles on the road. So now it says let L represent the total length of the road, and let D represent the number of days. So instead of per day, we're going to write times D. Per means multiplication, and D instead of day. And then this is going to equal, if I add 58 miles plus the miles that they've done that day, that's going to be the total length of the road, right? So the length of the road, L, is going to equal 58 plus 3 times D. And I'm leaving off the word miles because we don't want to necessarily put that into our equation there, right? That'd be a little confusing, so we can leave that part off while we're doing our calculation. So I have capital L equals 58 plus 3 times D. So there we go. We have our equation. Now we can figure out, using this equation, what the total length of the road would be after 33 days of work. So I know this is going to be 33. Instead of D, it's 33 now. I started with 58. And for each one of those 33 days, we added an extra 3 feet. So it's 3 per day. So I'm going to multiply this. 33 times 3 is 99. So they added an extra 99 miles to the road. We already had 58 miles. So we need to add these two together. So let's see. We get 17. And then we get 15. So I just did that kind of quickly. But I did 8 plus 9 is 17. 9 plus 5 plus 1 is 15. So the total length of the road is 157 miles now. They're working pretty darn quick there. Oh, why didn't the D go on there? That was silly. I didn't notice it didn't type the D on there, or I erased it. Alright, I do like that feature that it doesn't just immediately mark you wrong, it gives you a chance to fix it. That is a pretty nice little feature there. All right, last one here. We have the table shows the time in minutes that it took Bob to read different books of pages, read different numbers of pages in his book. Using X for the number of pages and Y for the time, do the following. Plot the ordered pairs described by the table. Write an equation relating X and Y. So it's giving us some very specific directions. Plot the ordered pairs described by the table. So let's go ahead and plot these ordered pairs. So keep in mind, and I know I did this in class when we went over this one, you can rewrite these if you want to as ordered pairs, if that helps you. They're kind of nicely written in this table, so it's not, you know, super crazy. There's nothing in between them. But remember, they are ordered pairs. 4 and 16. And remember, an ordered pair is a direction system. Positive tells me I'm going to go up. And they're all positive, so I'm going to go up 1. I'm going to go up 2. I'm going to go up 3. I'm going to go up 4. And with 4, 8, 12, and 16, they're all positive again, so I'm going to go to the right. So it's just telling me where to go here. So if I have 1 page, it took him 4 minutes to read that 1 page. If I have 2 pages, it took him 8 minutes. 3 pages, it took him 12 minutes. And 4 pages, where is it? 16. Oop, there we go. Okay, so I can see this. It's going up, 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 up. And if I notice, it's going up 4 each time. Right? Every minute we go up, it's another 4 minutes. Or every page we go up, it's another 4 minutes. That's a relationship that we actually want to pay attention to. So we want to think about, where did we start? Before he started reading his book, where was our starting point? So our starting point would have been 0, right? He hasn't read any pages yet at the starting point. When he started reading the book, he was literally on the beginning of the page. He hadn't opened it quite yet. So we have a starting point of 0 pages. And he's adding 4 pages per minute. Right? So we noticed this happening already. We could see it in the table. There's 4 plus 4, 8 plus 4, 12 plus 4. Or we can see it here. I can go up 4, and I'm going over 1 minute. Or over 1 page, sorry. Up 4 more minutes, another page. Up 4 minutes, another page. So this is 4, sorry, I wrote that backwards. 4 minutes. I just realized I wrote it backwards. Per page. Ha ha ha. That's the correct way to say it. Right? Because the number of pages, it takes them 4 minutes each time to read a page. That's what it sounds like. And they're asking us to relate X and Y. So they want us to do the number of pages is X. So it's going to be times X instead of per page. And the total is going to be Y. So let's think about how we can write an equation for this. Y, the total number of pages he read, is going to equal his starting point, which was 0, plus the number of minutes per page. That's going to be his total time, necessarily. I said total pages. I keep flip-flopping my words here. But so his total time will be the 4 minutes per page. We don't really have to put plus 0. I don't have to say 0 plus for my starting point, because that doesn't really mean anything. So we're going to ignore the starting point and just act like it's not there. We remember, if we don't see a starting point, it means that it's at 0. Okay? So he reads 4 pages per minute. So we just write X. 4X. All right, so let's see. We have Y equals 4X. So this also tells me that I'm multiplying X by 4 to move forward. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. See how that pattern works? So that actually does work out very nicely for us. All right, so that was section 1. I will see you in section 2.